Hello everyone, this is the 5th video of Unit 1. This video should be watched Wednesday 9/14. So we're going to be finding more limits, guys, and today we're going to be focusing on non-existent limits. Okay, so to review, when you think of limit, think of the final, utmost, or furthest boundary. That's the dictionary definition, the non-math definition, but which still applies in math. And keep in mind that the limit of a function exists if and only if both the left hand and right hand limits exist and are equal. There are 3 types of non-existent limits. Example number 1, the limit as x approaches 2. Now notice there's not a plus or minus as a superscript here, so just the plain old limit, guys, not from the right, not from the left, is applying both the limits from both sides. Okay, and if the limits from both sides are green, that is the limit of the function. Okay, so if you wanted to, you could even put, this is small, but you could even put like a little plus and a minus there. That actually doesn't look very good. But you could put a little plus and a minus because the limit is the limit from both sides. Okay, so if you are in a situation where the limit as x approaches 2 from both the left and the right, because that would be the actual limit of a function, if you know that that is infinity, okay, so as x, what is happening here, guys, we have a situation where x is approaching 2, and as our x values get closer and closer to 2, our y values are approaching infinity. So I'm taking this limit notation, I'm translating it to like an arrow diagram situation. So the situation here we've got, guys, is that of a vertical asymptote. So I'm drawing an xy axis. My x values are approaching 2, so I'll put 2 right there. And as my inputs or my x values approach 2 from both the left and right, the y values are shooting up toward infinity. Okay, so here is a graphical representation of the first situation. Okay, second situation, very similar, except as my x values are approaching 2, my y values are approaching negative infinity. I've got to work on my infinities. Okay, so xy axis, there's 2, okay, and this time my y values are approaching negative infinity. Okay, so they're getting lower, more and more and more negative without end. Okay, now here, so because infinity and negative infinity, those are not concrete numbers that we're approaching. So both of these situations, there is no limit. The limit does not exist. But then, guys, we have another situation of non-existent limits where it's not positive infinity, it's not negative infinity. The limit just plain old does not exist because from the left and right, we do not have an agreement on the y values that we're approaching. So I just split this box because I'm going to do 2 examples. So you could have a situation where you have an asymptote. Okay, so let's say that we still have an asymptote at x equals 2, and as we're approaching 2 from the left, the y values shoot up to positive infinity, and as we're approaching 2 from the right, the y values shoot down to negative infinity. So there's a situation we can't say that the limit is positive or negative infinity because from either side it's not agreeing. So there's just, it does not exist. You could also have a situation, I'll just draw a piecewise function here, where you don't have an asymptote. All right, so there's the x value 2. And let me do an open circle just above 2, and I'll say that to the left of 2, for that, on the x values less than 2, we just have this line. And then let's say to the right of 2, let's say the y value jumps up and I fill it in here, and then I just have like, I don't know, some polynomial like that. Okay, so here would be another situation where the limit would not exist. Okay, so what we're going to do today, guys, is we're going to find the following limits without a calculator. We're going to state any vertical asymptotes. A vertical asymptote is a situation like one of the first two, where x is approaching some finite actual number, but y is approaching positive or negative infinity. All right, so we're going to state any vertical asymptotes. And guys, I'm going to add something here. I'm going to say also draw a sketch. Also draw a rough sketch of any vertical asymptotes. If we cannot determine the limit by estimating, we're going to say can't tell. We're not going to use a calculator today, guys. We're just going to try to estimate. Okay, so the estimating here, this is a useful skill. Now, I'm going to go, or actually I'll do it right over here. We have to understand a couple things before we move on. Okay, so over here, let me say note. I'm going to use +0 to indicate a very small positive number, like 0.0000001. Okay, that would be like positive 0. It's not 0, but it's very, very close to 0. And then other side of the same coin, -0. This is going to be a very small negative number, like -0.000000001 or something like that. Okay, so I'm going to be using those. Alrighty, here we go. So this is how you do these examples, guys. We're not going to do all of the problems in this video lesson because that might get a little too long. Okay, so here we go. We'll do the first, we're just going to do the first 3. All right, the piecewise one I'll do in class. Okay, so when I'm estimating these limits, or when I'm using estimation to find them, I'm going to do 2 arrow diagrams. So first I'm going to approach 2 from the right, and then I'm going to approach 2 from the left. All right, so we'll do the right one first. So we have to see, remember, the limit of a function exists if and only if both left-hand and right-hand limits exist and are equal. So we're going to do the left-hand limit, the right-hand limit, and we're going to compare those. Now, as I'm approaching 2 from the right, what are some numbers to the right of 2 but very, very close? Guys, this is optional, these little numbers I'm writing, but they might help. So 2.1, I got to think like 2.1, 2.01, 2.001. Those are numbers to the right of 2 and getting closer and closer to 2. All right, so I have to ask myself, by estimating, as x is approaching 2 from the right, what are my y values approaching? So this is the function here, this rational function, x squared minus x minus 6 over x squared minus 4. Now this is a fraction, so right now I'm just putting down a fraction bar. Okay, you don't have to do that now if you don't want to. And I ask myself, I can ask myself, what is the, as x approaches 2 from the right, what is the numerator getting closer to? What is the denominator getting closer to? Okay. So 2 from the right, like 2.001, if I plug that into the numerator, I've got, for this first term, about 4 minus about 2 minus 6. Okay, I'm imagining plugging in like one of these numbers and getting closer and closer to 2 from the right. So about 4 minus about 2 minus 6, that is about -4. All right. Okay, so here, this is just an estimation. So I've got about -4 in the numerator. Now, in the denominator, if I plug in a number close to 2 but to the right of it here, and for that x, I'm going to have a little bit over 4. Okay, so a little bit over 2 squared is a little bit over 4. So a little bit over 4 minus 4 is very, very close to 0, but a positive number. So I'm going to say positive 0. All right. And now below, I'm just going to simplify that. So y is approaching -4 over a very, 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 very small positive number. Okay, so y is approaching what? Well, guys, the closer I get to 0, or I'm sorry, the closer I get to 2, the smaller and smaller that denominator, that positive 0 number gets. So, I don't know, you should be thinking ahead of me, like what could y possibly be approaching? Well, I'll go -4 divided by 0.0001. Okay, that's like what I mean when I say positive 0. That's a pretty big number. Now let me get even closer to 0. Negative 4 divided by 0.000000. It's hard to say 0 over and over. That's an even bigger negative number. So y is approaching negative infinity. Okay, I'm going to do the same thing from the left. Okay, so I'm going to write some numbers underneath 2 from the left as examples. So like 1.9, 1.99, 1.999. You don't have to write these, guys. Okay, I'm just writing them to help you with your estimations. So y is approaching, I'm opening up a fraction bar. Okay, I'm plugging in numbers very, very close to 2, but just a little bit under 2. So again, I'm getting about 4 minus about 2 minus 6. That is again very close to negative 4. Now, these numbers are right below 2. So I'm plugging in a number a little bit less than 2, and I'm squaring it. A little less than 2 squared is a little less than 4. A little less than 4 minus 4 is a very small negative number. Okay? So here, I've got the same situation, except I'm dividing by a very, very small negative number. All right? So let me just do one example from before, or very similar to before. I've got negative 4 divided by, let's do negative 0.000001. Okay, that's a big negative number, or positive. That's a big positive number. So the y's are approaching positive infinity. Guys, we do not have an agreement here. From the right, the y's are approaching negative infinity. From the left, they are approaching positive infinity. This limit up here does not exist. Okay, just plain old does not exist. We can't say positive or negative infinity. And I'm going to state any vertical asymptotes, but I'm also going to draw a rough sketch of them. Let me draw a rough sketch before I state it. So here is going to be my rough sketch. All right, there's the x value 2. As my x values are approaching 2 from the right, the y values are shooting way down to negative infinity. So I'm going to have an asymptote like that. Okay. And then from the left, my y values are shooting up to positive infinity. So it's going to be something like this. This is a very rough sketch, guys. Okay, the only thing that's going to make this sketch correct or not is whether or not you have an asymptote and how the function's behaving near it. Okay, like this part could have been lower, it could have been higher. As long as you have that asymptotic behavior, you're good to go. And this asymptote, the equation of it is x equals 2. Okay, a vertical asymptote will always, its equation will be a vertical line. So it does not exist, oh, sorry, I should say VA for vertical asymptote, colon, x equals 2. Okay, so we're going to flip to the back, guys. We've got 2 more examples. And I'll try to go a little bit faster. Alrighty. So this time I'm doing the limit as x approaches negative 3. So from the left and right, x approaches negative 3. I'll do from the right first. And x is approaching negative 3 from the left. And I'm going to write some numbers underneath negative 3 that are very close to it from the left and right. So like negative 2.9, negative 2.99, etc. And then from the right, or no, left, sorry, that's left. Negative 3.1, negative 3.01, okay, etc., getting closer and closer. Alrighty, so what about the y values? Y approaching, I've got another fraction, so I'm just doing a fraction bar. I like to do that first. Okay, a number very, very close to negative 3 plugged in up here. What's that going to get me? About negative 3, very close to negative 3 cubed is very close to negative 27. So I've got about negative 27 in the numerator. And in the denominator, I'm pretty close to -3, but on the number line to the right of it, okay, so let's just say this is about, if I plug in like -2.99999 plus 3, I'm going to get a very small positive number. So this is like +0, absolute value of it. All right, so I've got a very small positive number there. Well, guys, -27 divided by an extremely small positive number, which is just getting smaller and smaller and smaller because we're taking a limit, is going to earn us a very big negative number. All right, and if that doesn't make sense to you, plug in your calculator -27 divided by 0.0000, lots of zeros and a 1, and you'll see that that is tending toward negative infinity. They're just getting bigger and bigger, those numbers, but bigger and bigger negatively. Okay, over here, my y's are approaching. Again, I've got about -27 in the numerator, and in the denominator this time, like if I plug in -3.01 here plus 3, I'm going to have -0.01, but I'm taking its absolute value. And as I get closer and closer to -3 from the left, I'm just going to get a smaller and smaller negative number, but I'm taking the absolute value of that. So again, we've got +0. So y is approaching negative infinity again. All right. So the limit doesn't exist because the y's aren't approaching like a concrete number, but since the y values are agreeing, they're both approaching negative infinity, instead of saying does not exist, I'm going to be more specific for my reader and say negative infinity. Okay? Now I'm going to draw a picture of what this looks like, and then I will state the equation of the vertical asymptote. All right, so x is approaching -3. Right. And from both the left and the right, my graph is going down like that. Okay, so it's going to look something like that. And I can see that the vertical asymptote I'm working with, its equation is x equals -3. Okay, so there's that. Alrighty, guys, one more. Okay, the limit as x approaches 5. So first I look at it from the right, then I look at it from the left, or you could look at the left first. That actually feels a little more natural to me, but I was doing it this way. Okay, so I've got to imagine to myself, you could write the numbers below 5 like I was doing before if you'd like. I'm imagining approaching 5 from the right. So 5.1, 5.01, 5.0001. And I'm imagining plugging those numbers in up here. All right, so I've got about 25 minus about 15 minus 10. 25, about 25 minus about 15 minus 10. Guys, that's very, very close to 0. All right. So I'm getting a number in the numerator that is very, very close to 0. All right. Now in the denominator, I imagine like plugging in here 5.00001 minus 5. That is a number very close to 0, but it's positive. It wasn't clear to me whether the numerator was positive or negative, so I didn't write plus or minus next to it. And guys, what we have here is 0 over 0. That is what's called an indeterminate form. 0 over 0 is an indeterminate form. We cannot tell anything that's happening. So y is approaching can't tell. All right, 0 over 0, you can't tell. All right, if it was like 1 over positive 0, that would be a very big number. But 0 over 0, we can't tell what that is. Alrighty, and then on the other side, y is approaching, again, 0 in the numerator. And in the denominator, like 4.99999 minus 5, I've got a negative, very small number. But again, I can't tell what that is. So the answer to this one is can't tell. Okay, so moral of the story there, 0 over 0 is can't tell. Don't even think about it further. You get 0 over 0, you can't tell. I'm going to show you something in the future that we'll have to do if we have 0 over 0. Okay, guys, that was kind of a long video. So what I'm going to do is I'm going to cut down the homework significantly. Page 12, 1 and 2. Okay, only the first two on page 12, just so you can kind of get the hang of it. So page 12 homework, that's from the homework packet. Okay, so homework packet, numbers 1 and 2 only. Okay, that's the homework packet, page 12. Okay, guys, I'll see you tomorrow. Bye-bye.